We're diving deep into the brand new Flutter 3.32 update. It's packed with exciting improvements, and we're going to explore each one in detail. Let's kick things off with a feature that web developers have been eagerly waiting for: experimental hot reload for web applications. Historically, achieving a true hot reload experience on the web has been more challenging compared to mobile. Web browsers typically require a full page refresh to see code changes, which means you lose the application's current state. This can be quite disruptive to your workflow. Flutter 3.32 introduces experimental support for hot reload in web applications. Now the developers will be able to see the changes made to the code instantly in the running web application, without losing the current application state. This significantly speeds up the development process for web apps, bringing it closer to the experience of developing for mobile with Flutter. To try out this experimental feature, in VS Code, add this configuration to your launch.json file. Run your app using this configuration. Now let's see this in action. I have a very basic Flutter web application running here. The home screen is the home route, where we have this text, "This is the home screen," and a button to navigate to another screen called Web Hot Reload. In this nested screen, as well, we have a simple text widget, which we will update to see how hot reload works. In previous versions, when we update the code and save it, we can see it reloads the entire web app and our app state is lost. We are back to the home screen now. To see what we update, we have to navigate to the nested screen each time. This is very frustrating for the developers and wastes a lot of time. Now let's test the same with Flutter 3.32. We can see the updated text in the nested screen appears instantly. We didn't have a full page refresh. The application state was preserved. This is the power of hot reload now coming to Flutter Web. Now, remember that this is an experimental feature. You might encounter some limitations or even bugs. Next up is an exciting addition to the Flutter widget library, the new Expansible Widget. This widget provides a more flexible and customizable way to create expandable content in your Flutter applications. It offers more control over the expansion behavior and appearance compared to the existing expansion tile. Here's a basic structure of how you might use the Expansible widget. The expansible is expanded or collapsed with an animation driven by an animation controller. We have to provide header builder and body builder callbacks to build the header and body widgets. The expansible does not inherently toggle the expansion state. To toggle the expansion state, call expandableController.expand and expandableController.collapse as needed, most typically when the header returned in header builder is tapped. In the body builder, you can build the widget of your choice. You're not limited to just text in the header. You can use any widget, allowing for more interactive headers. For example, you might want to include an icon that visually indicates the expansion state. As you can see, we have our header text. When I tap on it, the body content smoothly expands into view. Tapping it again collapses the content. This basic implementation already provides a clean and functional expandable section. The Expansible widget can also be nested, allowing you to create complex hierarchical expandable structures, like multi-level menus or detailed breakdowns within sections. Okay, let's delve into another exciting addition to the Flutter widget library, RawMenuAnchor Widget. In many applications, you need more control over the presentation and behavior of menus than what the standard pop-up menu button or even the drop-down button offer. You might want to trigger a menu based on different interactions, position it in a specific way, or have a completely custom look and feel for the menu items. The RawMenuAnchor widget provides a foundational building block for creating these highly customized menus. It gives you the flexibility to define how and when the menu is shown, and what the menu content looks like. Here's a basic example of how you might use it. The menu controller is responsible for managing the open and close state of the menu. This is a builder function that defines the widget that will trigger the menu. It receives the build context, the menu controller, and an optional child widget. Inside the builder, we are returning a gesture detector wrapped around a container with the text Open Menu. The on-tap of the gesture detector calls controller.open and controller.close to show and hide the menu. The builder gives you complete freedom over what triggers the menu. We can customize the widget as we want. Like, we can use the icon button instead of the custom button. When a RawMenuAnchor is opened, Overlay Builder is called to construct the menu contents within an overlay. The overlay allows the menu to float on top of other widgets. The info argument passed to Overlay Builder provides the position of the anchor widget, the tapRegionGroupID for the menu system, and the position offset passed to menuController.open. We can use this info to set the position of the floating menu widget. Here, we've created a simple container with Inkwell widgets acting as menu items. When an item is tapped, we print a message and call controller.close to hide the menu. You can see our Open Menu button. When I tap it, our custom-styled menu appears. Tapping outside the menu doesn't automatically close it in this basic setup. We've explicitly closed it in the on-tap of our menu items. This demonstrates the level of control RawMenuAnchor gives you. Next is the refined Cupertino Squircles. In Flutter 3.32, the shape of these squircles within the Cupertino widgets has been refined. The Flutter team has aimed for a more accurate and visually appealing representation of the native iOS squircle. While it might seem like a small detail, these subtle visual cues can significantly impact the overall perceived authenticity and polish of your Flutter iOS applications. Let's take a look at some examples. Here, we have a container with rounded corners. Then we wrap the image in the CarouselController widget. We have also an example of using Custom Painter. We are using canvas.drawOurSuperlips to draw the rounded corners. Pay close attention to the curvature of the corners of all these widgets. You might notice that the newer version has a slightly more pronounced squircle shape, appearing less like a simple rounded rectangle and more like the characteristic iOS form. You don't explicitly set a squircle shape as a property in most Cupertino widgets. Instead, it's the default behavior of how rounded corners are rendered in certain contexts. Here are some basic Cupertino widgets like a button and a text field. Observe the rounded corners of the Cupertino button and the Cupertino text field. These corners will exhibit the refined squircle shape. You might still use borderRadius.circular with Cupertino widgets to control the roundness of the corners. The underlying rendering will now apply the refined squircle algorithm when interpreting these corner radius. Here, we're explicitly setting a border radius to a Cupertino button. The Flutter framework will still render these rounded corners with the updated squircle characteristics. The Flutter 3.32 update brings a visual enhancement to the Cupertino library with refined squircle shapes, now consistently applied to Cupertino Alert Dialog and Cupertino Action Sheet for a more authentic iOS appearance. So, the developers can now leverage the new rounded Superlips APIs, including rounded Superlips border for painting and widget shapes, ClipRSuperlips for clipping, and lower-level canvas and path methods for direct control over this unique shape. Talking about the Cupertino sheet, there are various fixes and improvements made in Flutter 3.32. This update addresses issues with the navigation bar's height and ensuring content isn't cut off at the bottom within a Cupertino sheet. The sheet's layout has been adjusted to correctly calculate the navigation bar's height and ensure that all content, especially scrollable content, is fully visible and not truncated at the bottom of the sheet. In this update, the new enableDrag argument is available on Cupertino Sheet Route and Show Cupertino Sheet. By default, Cupertino sheets are dismissible by dragging them downwards. The new enableDrag argument allows you to explicitly control whether a user can dismiss the sheet by dragging it. Next up is the enhancements made to navigation bars, specifically focusing on the Cupertino Sliver navigation bar. The first specific improvement is the correct alignment of the search field's prefix and suffix icons within Cupertino Sliver navigation bar.search. In previous versions, there might have been slight misalignments or visual inconsistencies with the prefix and suffix icons within the search text field, especially during animations or on different device configurations. Flutter 3.32 addresses these fidelity issues, ensuring these icons are perfectly aligned and behave as expected, contributing to a more refined visual experience. The second key enhancement is that the transition between routes with Cupertino navigation bars or Cupertino Sliver navigation bars has been updated to match the latest iOS transitions. iOS has a very distinct animation when pushing or popping screens, especially with navigation bars. The title, back button, and other elements often slide and fade in a specific way. Flutter 3.32 has fine-tuned these animations to align more closely with the current iOS behavior, providing a smoother and more authentic navigation experience. Now let's talk about some feature enhancements and bug fixes to the material library in this update. One of the exciting feature enhancements in the material library is related to carousels. The CarouselController now provides a more convenient animateToItem method. This method enables smooth, index-based navigation for your carousels, whether your items have fixed sizes or dynamically sized items using flex weights. Previously, achieving smooth, index-based navigation, especially with items of varying sizes, could be a bit more complex. The new animateToIndex method simplifies this significantly. Here is an example of a carousel view with some navigation buttons. This code defines a carousel of 7 differently colored items, using a custom carousel view widget. It includes buttons to navigate to the previous, next, first, fourth, and last items in the carousel, with the navigation being animated using a CarouselController.animateToItem to smoothly transition between items, and the current item index is tracked and used to disable the previous and next buttons when at the boundaries. We can see the smooth transitions between the items at any index of the Carousel Children widgets. The animateToItem method is particularly powerful because it's designed to work seamlessly with carousels that have dynamically sized items using flex weights. In many carousels, not all items are the same width or height. Imagine a product carousel where some product cards are wider than others, or a news feed where article previews have varying heights. Flex weights would allow the carousel layout to understand and account for these varying sizes, ensuring that animateToItem can accurately calculate the scroll position needed to bring a specific, potentially dynamically sized, item into view smoothly. This is a significant improvement over controllers that might only work well with fixed-size items. Next feature enhancement is new callbacks for the TabBar widget, on-hover and on-focus change. These additions provide developers with more granular control over the TabBar's appearance and behavior in different interactive states. Especially on desktop and web, require richer interaction models. Users interact with these platforms using mice for hovering and keyboards for navigation. These new callbacks allow you to respond directly to these interactions, enabling more dynamic and accessible UI. First up, we have the on-hover callback. This callback is invoked when a mouse pointer enters or exits the region of a TabBar tab. It provides a Boolean value, true if the pointer is currently hovering, and false if it has left. This is incredibly useful for providing visual feedback, like highlighting a tab when the user hovers over it. Here we are changing the color of the tab icon. Next we have the on-focus change callback. This callback is triggered when the focus state of a TabBar tab changes, typically due to keyboard navigation, for example, using the tab key. It also provides a Boolean value, true if the tab has gained focus, and false if it has lost focus. This is crucial for accessibility and keyboard-driven interfaces. Here we are changing the tab tile on focus change. Next update is in the SearchAnchor and SearchAnchor.bar widgets, which have received new callbacks, view on open and on open. These provide better observation and handling of when the search view opens and closes. While these widgets provide a seamless user experience, developers sometimes need to know exactly when the search view opens or closes to trigger specific actions, such as logging analytics, fetching initial data, or managing other UI states. These new callbacks give us that precise control. Let's start with the SearchAnchor widget. This is the more flexible version, where you provide a custom widget to trigger the search experience. It now includes a new callback called view on open and its counterpart view on close. These callbacks are invoked when the full search view, which appears over your content, is opened or closed. I've set up a simple search anchor with an elevated button as its trigger. Notice the view on open and view on close properties. Inside these, we're updating a text widget to show the current status. When I tap the Open Search Anchor button, you'll see the status text update to opened. When I close the search view, either by tapping the back arrow or selecting a suggestion, the status changes back to closed. This allows you to react precisely to the visibility of the search overlay. Now let's look at SearchAnchor.bar. This widget provides a more integrated search bar experience, typically placed directly in an app bar. It now includes the on-open and on-close callbacks. These are triggered when the SearchAnchor.bar itself is tapped, initiating the search view. Similar to SearchAnchor, I've added a SearchAnchor.bar to our screen. Observe its on-open and on-close properties. When I tap this integrated search bar, the on-open callback fires, updating our status text. When the search view is dismissed, on-close is called. This is particularly useful for scenarios where the search bar itself is the primary trigger for the search experience. Next new feature is for the CalendarDatePicker widget, the CalendarDelegate. This addition opens up a world of possibilities for customizing calendar logic beyond the standard Gregorian system. While the default CalendarDatePicker is perfect for most applications, there are scenarios where you might need to display dates according to a different calendar system, like the lunar calendar, Hydri calendar, or even a completely custom fictional calendar for a game or specialized app. Or you might need to alter the fundamental rules of how days, weeks, and months are structured. Flutter 3.32 introduces the CalendarDelegate property to CalendarDatePicker, and consequently to ShowDatePicker. This property accepts an instance of CalendarDatePicker Delegate. By providing your own custom implementation of this abstract class, you can define the core logic of how a calendar behaves. For demonstration purposes, I've created a hypothetical calendar system where even months have 21 days and odd months have 28 days. This is the code for our custom hypothetical calendar delegate and how we pass it to ShowDatePicker. To make it simple, hypothetical calendar delegate extends the Gregorian calendar delegate class, which is the default calendar system for CalendarDatePicker. We can override methods from CalendarDelegate class according to our requirements. Here I have override this getDaysInMonth method to set the custom month length logic. If the month is even, it returns 21 days. Otherwise, it returns 28 days for odd months. Now, let's see our custom calendar in action. Notice the number of days in a month. January, month 1, odd. It has 28 days. February, month 2, even. It has only 21 days. March, month 3, odd. Back to 28 days. April, month 4, even. Back to 21 days. This clearly demonstrates how our calendar delegate is overriding the default Gregorian calendar rules. This level of control is incredibly powerful for specialized applications. There are some smaller, but very impactful material enhancements and crucial bug fixes within the material library. These updates improve both functionality and the overall developer experience. First, we have a great addition for customizing the user experience of dialogues. ShowDialog, ShowAdaptiveDialog, and DialogRoute now accept an animation style property. This allows you to customize the animation when the dialog is opened and closed, giving you more control over the visual flair of your pop-ups. The animation style property takes an animation style object, which allows you to define custom curve and duration for the entry and exit animations. This means you're no longer limited to the default dialog animation. You can create unique and engaging transitions. When I tap Show Dialog with Custom Animation, notice how the dialog doesn't just pop up. It scales in with ease out and fades with bounce animation. This allows for a much more dynamic and branded dialog experience in your app. Next is the divider widget now accepts a radius property. This allows you to customize the corners of the divider, especially useful when you have thick dividers in your UI. Previously, thick dividers would always have sharp, rectangular ends. Now you can give them soft, rounded corners, which can significantly improve the aesthetic appeal and consistency with Material 3's emphasis on rounded shapes. In our code, we're applying a radius of 5 to it. Observe this thick orange divider. Instead of sharp edges, it now has subtly rounded caps, making it look much more modern and integrated with a rounded design language. Moving on to some crucial bug fixes, the DropdownMenu widget has received an important update. It now allows its menu width to be smaller than the text field. This resolves a common RenderFlex overflow error that developers encountered when menu items had very long labels compared to the selected text field's width. The default width of DropdownMenu now also correctly respects the width of the text label in the text field. Before this fix, if you had a drop-down menu where one of the options was significantly longer than the space available in the selected text field, the menu might try to expand to fit the longest item, potentially causing an overflow. This is now handled gracefully. Our example drop-down menu includes an option with a very long label. When I open this drop-down, notice that the option B with a very long label that might cause RenderFlex overflow doesn't cause the entire drop-down menu widget to overflow its parent. The menu intelligently adjusts its width, preventing layout issues. This is a fantastic quality of life improvement for drop-down menu users. Another subtle but important bug fix is for the range slider. When hovering over a range slider thumb, only the overlay of the hovered thumb now appears. Previously, both overlays would incorrectly show up, which could be visually confusing. This fix ensures that the visual feedback for hovering is precise and only applies to the specific thumb the user is interacting with. See this in action. When I hover my mouse pointer over only one of the range slider thumbs, you'll observe that only that specific thumb's overlay, the circular highlight, appears. The other thumb remains unhighlighted, providing clear feedback. Finally, for the slider widget, a limitation has been overcome. The slider thumb can now reach both ends of the track, even when the track color is transparent. Previously, there could be a slight visual offset or inability to reach the absolute ends if the track itself was transparent. This fix ensures that the thumb's movement range is accurate and visually correct, regardless of whether the track has a visible color or not. This is particularly useful for highly customized slider designs. Our example slider has its active track color and inactive track color set to colors.transparent. When I drag this slider, notice that even though the track is transparent, the thumb can smoothly reach the absolute minimum 0.0 and maximum 1.0 positions on the track. This provides full control and visual accuracy for your custom slider designs. These feature enhancements and bug fixes in the material library for Flutter 3.32 collectively contribute to a more robust, flexible, and visually polished material design experience. They demonstrate Flutter's continuous commitment to improving end-user interfaces.